Hello, my name is Carlos Villegas. I'm going to present to you Linux log analysis. So let's start off first by explaining what Linux is at a high level. Linux is a very popular operating system, as you may already know. Most of the internet runs on it, and it's open source. It runs on many types of devices, really small ones from the cell phone in your pocket or backpack to supercomputers hosting thousands of CPUs. It was created in 1991 in about 4 months, version 1.0 in Finland by a student just like you guys called Linus Torvalds. So back in 1991, hard drives weren't too popular. Only very exclusive organizations had them. It was more common for everybody that was fortunate enough to have a computer at home to use floppy disks, as you see in this photo right here in front of you. These contain a very early version of Linux. These are 5¼ inch floppy disks, by the way. Since this presentation is about Linux log analysis, and we've already spoken a little bit about Linux, let's define what a log is. A log is a file that contains information about past events. Most logs are in plain text, although some are in binary and even encrypted. There's a directory on the Linux file system called var log, and it contains most of the logs. However, a few logs reside in other directories, namely the var run, and an example of a log file in that directory would be the utmp log file, which will give you a complete picture of a user's logins from what terminal, logouts, system events, and current status of the system boot time, uptime, etc. Why is log analysis important? What does it tell us? Why do we need to study it? Log analysis is very important because it tells us what happened and who did it. And those are very important answers to digital forensic professionals. An analogy would be in Australia, you hire a tracker to find a specific type of animal, and that tracker is going to scour the environment for clues. Among those clues, he or she is going to look for footprints, and is going to take you right to the animal so that you can photograph it. So what does a log look like? As mentioned before, most logs are in plain text, and here are 3 examples. All 3 examples contain different information coming from 3 different logs. Notice how the formats are different. Notice how date, time in each log is different. The first one, for example, gives the date time at the very beginning, followed by some text. The second log example puts the date and time at the end rather than at the beginning. And the third one doesn't even give you a date time, but rather an offset from when the computer was booted up. The last one particularly gives you the time clock in one of the log entries, which then you use for every other entry to calculate the absolute date time for it. So let's start getting into which logs are of forensic interest. The first one that I have and I wanted to tell you guys about is the Apache log files. There actually is not just one log file for the Apache, but rather there's a directory with a few, more like 5 or 6 log files within that directory. So the error.log file is important because the Apache log server this is where it sends diagnostic information and records any errors it encounters when dealing with all the requests that come in. By the way, Apache is a web server. It's an open source web server that is very popular in the internet, and it's multi-platform. It's not just Linux, but it is the most popular one used in Linux. So going back, this error.log file within the Apache log directory, this would be the first place you would go to troubleshoot any web server issues. The next log file is in the Apache log family is the access log, and this is where all of the requests get recorded. The next type of logs that are important for forensic investigators are those associated with authentications. And every modern operating system has authentication information, and it stores it in various logs. The most important ones are the auth.log, the auth log, and this is where whether your authentication attempt was successful or not, it gets recorded on there. So you can query that to see, hey, are my users or the users of this server, if you see a lot of bad entries in there, unsuccessful authentications, well, perhaps it's something of interest to look into. Or for successful ones, you can do some trending and see, hey, is this a normal amount of authentication based on my history for this web server? Is it normal, or do I have all of a sudden a rush of authentications that I should not expect? That's why logs are so important. The other one is the WTMP log, which is similar to the UTMP that I talked about in the previous slide. But this one is in binary as well, and that's why we have to use the last command to extract any login, logout, reboot information. So the last command should be used with the utmp.log file because it's in binary. As with the last log.log file, the third example down there is very similar, but a different command. We use the last log command. These logs are in binary format. Here are a few more examples of important logs in Linux. So you have global messaging logs, you have kernel keyring logs, you have database logs, you have daemon logs. Daemons are server processes that are running on a server unattended, and so when they find any salient information, they will log it to the log. And lastly, we have Samba related logging used for file sharing and network communication. This Linux log analysis presentation would not be complete without some Linux commands for dealing with logs. So these are the essential but not limited list of commands that will help you look and do some analysis and investigation on Linux logs. So let's get down to business in doing some log analysis. Could you do it by hand? Yes, absolutely you can. With the assistance of the commands that I listed in the previous slide, yes you can. You could even go a step further and use a scripting language or a compiled language and write your own tool analysis, or rather log analysis tool, and you'll see a boost in performance. However, there are many tools out there that are created by companies and people like you and me that have released them to open source to do some log analysis, and those, I think if you use those, it'll be more efficient. However, if you want to do it by hand, or you have this really cool idea on how to do things that the other tools haven't been able to implement, or don't have that idea, by all means go right ahead, implement your own tool and make it open source to share it with everyone else. I do want to point out a few pitfalls of analyzing logs manually. The first one on my list, that it's pretty boring, it's mundane, and the risk is that we miss a lot of things. When a task is boring, your mind is not in it, it's not focused in it, so you tend to miss a lot of important stuff. Also, human brain cannot catch everything because there's just too much information produced very fast, very quickly. There are a lot of events produced per second. We're talking in the thousands, sometimes in the hundreds of thousands, sometimes a few occasions in the millions. And just you can't process that information in your head, or even a group of people can't. You need computers. That's what they're good for. They're good for speed and repetition. Some are even good at attempting to think, but I don't think we're there yet. We're getting close, but we're not there yet. So here are some benefits of using tools to do log analysis. Tools can process information much faster than a human brain can. Tools can benefit speed and memory, hard disk or RAM, of a computer's resource. And by leveraging those two aspects, they can cross-reference things that we normally can't in two domains. The first one is location. For a computer, it's easy to interrelate or cross-reference two events or more in different logs that are related. Computers can do that. If you teach them, if you tell them to, they could do that. That's the first area that a tool can really excel at, that we would have a hard time doing. The other one is a time aspect of cross-referencing. When the UTMP log I talked about earlier stores information of when a user logs in, logs out, how long that user was using the machine, how long the session was, in other words, what terminal he or she logged in from, etc. Well, I mean, you could look at the log and maybe capture 2, maybe 3, 4 events, you know, log in, log out, log in, log out kind of thing. But when you start adding more sessions, or sessions that span a day, a week, a month, a year, we start breaking down and keeping that information in our heads. Computers can do it indefinitely. You know, give them a lot of disk space, they can store information. In fact, they do it right now with our medical records, DMV records, IRS records, you name it. They do it. You know, when you go return something at a store, they have a catalog of everything that you have purchased, associated with the receipt that you want to do that return on. They can keep that information stored indefinitely if they want. They don't for practical reasons, but they could. So this brings me to the last part of this presentation. What tools are out there to help us analyze logs in Linux? This first one is drew my attention because it's easy to set up, and it gives you a lot of good information. It's not only a tool, but it's a whole Linux distribution, especially crafted to assist you in network intrusion detection and network security monitoring. It's based on Ubuntu Linux, and it has a bunch of top-notch tools set up and configured already, and you can install this in big business enterprises, a small mom and pop shop, or even in your own home. You could install this within 15 minutes and you're good to go. It's called Security Onion. Check it out, please. It's really, really nice. The next tool I wanted to mention is a very important one that a lot of us sometimes take for granted or don't pay enough attention to this kind of service. This tool will help you manage your logs and keep them safe for a long time. It's called Log Stash. It's very important for forensic investigators to be able to recall a log with certainty, know that it will be there in 3 years, for example. Some court cases take that long, and you need a good tool to safeguard those logs. And it's open source, so it's a general purpose log management tool. I think it's very important also. And here are some screenshots of Log Stash. The next tool is a big tool, that should probably only be limited to installing it on enterprise environments, because, or medium-sized businesses, because it needs a client-server architecture. They call it a client manager or agent manager architecture. It basically is, you got all your servers out there that you want monitoring on. You install a client, a very thin and efficient client. So as you can see on the picture to your left, all the clients are down at the bottom. I keep calling clients. They're called agents. Install the agents down there. Those are thin, very efficient. They just forward it to the big manager slash server for this tool called OSSEC. It's open source. It does log analysis in real time, and it's if I were to do a tool, I would do it this way. But that server needs to be very hefty, very, very, very fast, have a lot of memory, because a lot of servers are going to be pushing data to it, so it needs to keep up and be able to process hundreds, thousands, tens of thousands maybe, depending on how many servers, how many agents you have out there, of events per second. But it does some. It can alert you. It could send you alerts in real time, and it's open source. I mentioned that. Very, very nice tool. StatLog Analyzer is another tool. It's also open source, gives you a lot of statistical graphics on various types of servers. You can use it with a GUI as with a command line. It's written in Perl, and it's multi-platform. Last but not least is Webalizer. It's an open source tool that was tested at CERN and written in C language, just like the Linux operating system itself. So it's very fast. You can right now copy this URL right there in the middle of the screen, paste it into your web browser, and it will take you to a page that has a lot of tables and graphics produced by Webalizer itself. Check it out. This concludes my presentation. I hope it was of some value to you, and I hope to have reached my objective of explaining to you what Linux log analysis is and why it's important. Thank you very much.